Your Influence in Space by Alexei Novitzky. Introduction. Your Influence in Space primarily discusses the concept of space preparation. In short, your light extends to the edge of the universe in at least one or more reference frames. We begin our journey by looking at the evolution of the human senses. We see that some senses come from evolving on Earth and some come from evolving around the Sun. The Doppler shift is examined and shows us how our light or influence can stretch and crunch depending on relative motions. Our journey then takes another look at gravity. Perhaps the force of gravity comes from planets acting as shields blocking an interstellar star pressure rather than them being the source of attraction. However, ultimately, it is all waves, and the nature of reality may be an overlapping of electromagnetic energies. We define the light state of the universe and introduce the liquid light state universe. The senses. Not only did we evolve on Earth, which revolves around the sun, but we also evolved in an expanding universe, hence our sense of time. Here we will take a look at the human senses. We will explore why we even have senses and where they came from. It is important to first explore these concepts because they are crucial for understanding our sense of space and time, and the concept of space preparation. Darwin's theory of evolution. Most of us are familiar with Darwin's theory of evolution. However, let's do a quick recap. It basically states that all life is related and extends from a common ancestor. Over long periods of time, these animals change to be better suited for their environment. Sensory evolution. First, it is important to discuss why beings even have senses, what they can sense with them, and why they may be considered beneficial for survival. We could go into much more detail on each topic, but considering this is simply a stepping stone for understanding of space preparation, we will keep this simple. While we discuss, keep in the back of your mind that physical existence is a combination of light and solid. More specifically, light creates the solids. Photons could be considered like electrons moving at the speed of light from atom to atom. However, different combinations of light create the physical world, and these combinations may fabricate themselves to be any particle in existence. In short, matter is composed of light. Evolving on Earth. Animals have been said to have evolved on Earth. This statement is a rather simple system when compared to the greater picture. Animals did evolve on Earth, yet they also evolved in a solar system. To take that one step further, evolution occurred within an expanding universe. For the senses of smell and taste, we have organs that detect physical particles. The organs in this case would be the nose and tongue. They send electrical signals to our brain and let our bodies know if action is needed or not. They can tell us if something is edible or not. If something tastes or smells bad, it is most likely not edible. They can warn our bodies of approaching dangers like fire. The scent of smoke is strongly recognizable. You could say that these sensory organs are tuned to what would allow the species to survive and reproduce. The case for reproduction is clear with pheromones. These senses have been designed through evolution on Earth to detect physical molecules. The nose and tongue are detecting molecules that are made of matter. Now consider the sense of hearing. Again, you are detecting physical matter, but at this time it is in the form of pressure waves. Pressure waves create the sounds you hear. The range of hearing is directly related to the frequency of a being's vocal cords. This is why we cannot perceive the highest pitches of a mouse and the lowest pitches of an elephant. Mice are tuned to a much higher frequency of sound, and elephants are tuned to a much lower frequency. However, the main point is that this sense is also detecting physical matter. The sense of touch is somewhat unique because it can detect molecules and light. Your sense of feeling comes from physically interacting with objects. You know that contact has been made because magnetic energy in your molecule is directly being interfered by the molecules of whatever you are touching. This is obvious. What might not be so obvious is that you can feel if something is hot or cold. The implications of this are much grander than you may think. Your sense of touch can actually sense temperature differences without contact. You could say that human skin has the ability to detect infrared energy. It may be safe to assume that it may also be able to detect slightly shorter and slightly longer wavelengths. This means that you can essentially see with your sense of feeling. In the simplest term, your skin can sense heat with no physical contact and only that of electromagnetic energy. The sense of sound, taste, and smell all come directly from evolving on Earth. Feel may be the first sense that gives us a clue of the sun. Evolving in a solar system. Not only did we evolve on Earth, but we also evolved in a solar system. For light, the organ would be the eyeball, and it detects electromagnetism. Light comes in many wavelengths, and similar to sound, eyes are best tuned to the environment in which they live. Again, to keep this moving towards space preparation and not be too sidetracked, we will keep this section short. The human vision is focused around the color yellow, which is the maximum wavelength of output emitted by the sun. The implications of this may be much more grander than we think. The senses of sound, touch, taste, and smell all came from evolving on Earth. Here we see the first trace of a sensory organ's evolutionary influence coming from space. Eyes detect electromagnetic waves that come from space. To keep it simple, the sun's light hits the Earth and then bounces around in many visible wavelengths. Similar to the ear's form of acoustic wave detection, the eye has a limited range of electromagnetic frequencies in which it may gather information. There are many wavelengths that the eye cannot sense. The eye cannot sense wavelengths that are shorter than blue or longer than red. Our eyes can only see an extremely small portion of the electromagnetic spectrum when compared to all possibilities in existence. The point, and I stress this point, is that light waves exist that we cannot detect, and the ones that we do are beneficial for surviving the current moment. Evolving in an expanding universe. The sense of time exists and is a result of evolving in an expanding universe, where light is able to move freely from atom to atom. The sense of time may be extremely hard to measure. Sure, you can measure how far light travels and use a pendulum, but all that varies according to your relativistic velocity. It could be safe to say that similar to waves like those from short to long of the electromagnetic and acoustic frequencies exist in time as well, and we have the ability to detect the one that is most beneficial for surviving the current moment. Now for time, this may be an obvious statement, but it is most beneficial to sense the now, and not the past or the future for your average animal. Every sense is ultimately filtered by your brain to give you a way to interact as best as possible with the environment. The past is solid and exists, yet we cannot physically see it. The present exists, and we can see it. The future will be solid, and it will exist. This implies that all future may be as solid as our past. Our sense of time is tuned to the now, because it is what is most beneficial for surviving the current moment and producing offspring. Limitations of physical medians. There are limitations to the medians in which our senses are tuned. We are now shifting over to talk about the accuracy of our senses to the physical environment. From the last section, we see that each sense has a threshold, a range of frequencies in which it may gather information. We also see that each sense is tuned to a certain substance or medium. For example, ears are tuned to acoustic waves which vibrate through physical matter. Typically, the median is air. However, you can put your ear on a desk and tap the desk, and now you are listening through a desk, which is made of the solid. Now the desk is the median. In both cases, the median determines the accuracy of your sense of choice. Accuracy, in this case, refers in your ability to locate the signal that you're searching for. In other words, where is the object you are listening for? For sound waves, the denser the median is, the faster the wave will travel. The faster the wave travels, the more accurately you may predict the location of the source, because there's less chance that it has moved. Very quickly and for fun, could there theoretically exist a density to where the velocity of sound wave is greater than the speed of light? It is important to recognize that sound has a maximum velocity at which it may travel through any medium, and it is generally governed by the density of the material. The basic equation is as follows. The speed of sound is equal to the square root of Bulk's modulus divided by density. You can clearly see that the velocity of the speed of sounds varies through different mediums. Let's do a quick thought experiment. Imagine if we did not evolve with eyes and only had ears. Our entire world and understanding of space and time would be solely based off sounds. We might think that the speed of sound is the fastest speed available as far as communications are concerned. The perceived locations of objects would be directly related to the speed at which it takes sound to travel. Acoustic waves would be the source of information exchange within our known universe. We would not know of stars and light because we would not have evolved with tools or necessary to do so. However, as humans, and having evolved with electromagnetic detection abilities, we know that light travels much faster than sound. For example, we can see lightning strike well before we hear the thunder. Knowing this, we think it's completely silly or even ridiculous to consider the speed of sound as the ultimate barrier, as far as physical matter moving through space. At least we are smarter than the worms. Understanding our senses is crucial for understanding our universe. Consider the earthworm in politics. The worm lives all day in the dirt and is extremely efficient at what it does. It eats and poops dirt. If you were to ask a worm about human politics, it would be clueless. It would not know if it was a Democrat or a Republican. The worm would not have a clue. This is because of two main reasons. The first is quite obvious. The earthworm has a small brain. The second is that the earthworm does not need to understand human politics. For that reason, it did not evolve with the tools necessary to do so. Remember, senses help us live in the now and reproduce. Although human politics may influence a worm's habitat through farming and other secondary means, the worm will never be able to fully comprehend what is happening solely because it does not have the senses to be able to. Will a worm ever truly understand human politics? The answer is no. Worms do not have the physical ability to comprehend such concepts. The worm is not physically or mentally evolved enough to understand with the same capability as a human as to what it means to be alive in the universe. The worm has no knowledge of other planets, comets, black holes, and etc. Those parts of existence have no influence on the worm's day-to-day survival. But we are not that smart. Compare humans to the earthworm. We are bounds and leaps ahead of them as far as technological advancements and knowledge of the stars is concerned. We can make art, complicated communications, build telescopes, and decipher the stars. But how smart are we really when compared to the most advanced life forms in existence? The Earth has been around for about 4.5 billion years, and humans roughly appeared 100,000 years ago. That's not that much time when compared to the age of the Earth, and especially when compared to the age of the universe, which is estimated to be about 18 billion years old. There could be life forms that have been around for 200,000 years, or even a billion years. These life forms could potentially have much more developed senses than we do. Humans to these theoretical aliens could be just as smart as earthworms are to us. Light is the source of information exchange. The fastest source of information exchange when it comes to natural human evolutionary senses is electromagnetism. Electromagnetism is light. The speed of light may seem very fast. It may seem almost instant. You can have a conversation with someone on the other side of the planet with little to no delay. This comes down to perception. Light appears to move fast to humans, but to the theoretical alien that may have more developed senses than we do, light may move extremely slow. The thought of communicating through electromagnetism may be equivalent to talking with someone with two cups tied together with a string. To give an example for a humanly understanding, imagine that this being can see and travel through wormholes with their natural body and no technology, just as easy as we can see the stars at night. The universe's greatest magic trick. Matter can travel faster than light, but it will not look like it. It is the universe's greatest magic trick. Consider the magician. They use lights and trickery to create an illusion. The reason why the tricks work is because they make you believe that something is happening when it is not. They will make a sound or show an image. People then think something is somewhere because they hear or see it. However, in reality, it is already in their back pocket. The same is true for light within the universe. The Doppler effect. The Doppler shift can be seen in many different waveforms. Again, let's consider sound waves for this example. Imagine a simple tone. Let's say it's a generic 100 units in wavelength. Now take the source of sound and give it a velocity in a direction that is either moving towards or away from you. You will notice that the wavelength will change accordingly. When compared to the stationary object, objects traveling toward you will have a higher frequency, and objects moving away from you will have a lower frequency. This is where things get a little tricky. Let's say the object is a train. When you are on the train, you won't really notice anything. The sound of the train will be a constant hum, or the wheels rolling on the tracks. Now let's say you are on the side of the tracks and the train comes racing by. The sound of the train will change as it passes. It will change from short waves while it is coming towards you to then being shifted to long waves while it is moving away from you. This is an example of the Doppler shift that may be seen in our day-to-day life. All wave types undergo a Doppler shift. The effect of the Doppler shift is directly related to the velocity and location of the wave source. In the previous example, the source would have been the train. The Doppler effect is also true for the electromagnetic spectrum. The electromagnetic spectrum may be broken down into many different wave types. However, for this section, it is important to note that all waves, X-rays, visible light, radio waves, gamma waves, and etc., are all forms of electromagnetic waves. They are all composed of the same forces that we physically see. The only difference is the frequency, or wavelength. The appearance of the electromagnetic wave is directly related to the original source of the wave and its velocity when compared to the observer. Let's now look at a simple example for light. Imagine a yellow light. It sits somewhere stationary in space. Now the light decides to come racing towards you at speeds relative to the speed of light. As the object comes near, the light waves begin to crunch. The light therefore has a higher frequency and looks bluer. As the light passes, you notice that it turns from blue to yellow to red. The light is now traveling away from you, so the wavelengths have been stretched. It now has a longer frequency because it is moving away. Another important factor that the speed of light is no matter how fast you are moving. Another important factor is that the speed of light is constant no matter how fast you are moving. This means that the apparent distances that the light has traveled may vary based on the observer. Let's now imagine we have a UFO that can accelerate at infinite velocity. Imagine we shine a beam of light for 1 second. Let's now generalize on the relative distances the light has traveled based on the speed of the observer. For this, we'll need 4 observers. Observer 0 is stationary on Earth, 0c. Observer 1 is flying at the speed of light, 1c. Observer 2 is flying at 2 times the speed of light, 2c. And observer infinity is flying at infinite velocity. A quick side, the theory of relativity says that nothing can travel faster than the speed of light. We are saying that that is an illusion created by the permeation of light within space and human consciousness. The trick. Ask yourself, how can anything ever look like it's going faster than light if light is the most advanced source of information exchange for human consciousness? The relative time dilations are still an important factor because that is how matter acts when it's in motion. However, what would 2 photons accelerating at the light speed in the same direction look like to another? They may appear frozen in space, like matter. Consider a particle accelerating at light speed. Try to imagine the light being emitted in front and behind. Here's a quick thought experiment to help you visualize the scenario. The force of gravity is 9.8 meters per second on Earth, meters per second squared for Earth. In order to lift off with a rocket, your acceleration needs to be greater than 9.8 meters per second squared. If it is less, you won't take off, but you would still weigh less. However, at exactly 9.8 meters per second squared, you will neither lift off or have weight. That would be the same effect as a photon being emitted from a particle accelerating at light speed. They would either be stuck in the direction of travel and appear to be mass, or emitted in the reverse direction. So is there a difference between light and matter, or is that just a result of your relative frame of motion? Is the matter we manifest with a result of light speed acceleration? Let's go back to the example of the UFO and yellow light, and while we are doing this, relate the amount of energy the wave has with the distance it has traveled. We will now shine the light for 1 second of time. Observer 0, the person on Earth not moving, experiences that the light has traveled 1c, 1 times the speed of light, and it looks yellow. Observer 1, the person traveling at 1 time the speed of light, sees the light has traveled 2c, and it looks redder. The wavelength is longer and the standing energy associated with the frequency is less. Observer 2, the person traveling at 2 times the speed of light, sees that the light has traveled 3c and looks even more stretched. The light may now be in the radio waveform and its frequency even less. Observer 3, A person at infinite velocity sees that the light has still traveled in front of them. It is at a distance of infinity plus 1c. However, the wave is so stretched that the energy associated is nearly equal to zero. When you take the quick snapshot of this scenario, you see that an object's light encompasses the entire universe in at least one or more reference frames. There is a bell curve associated with energy and distance from material center. It is interesting to compare this to Heisenberg's uncertainty principle because the bell curve shape associated with position and momentum seems to be related to this phenomenon. Our curve is directly relating the now standing energy with distance from center. This implies that your energy exists in all moments of space and time in at least one or more relative frames of motion. In other words, your light and therefore influence exist at the edge of the universe, but is most dominant and influential in your own relative frame of motion, in the physical space in which it resides. Space prepares itself before matter shines. Every particle or wave of light exists at all places and moments in time in at least one or more reference frames. In other words, everything is somewhat everywhere, but your energy is strongest in your own frame. Now let's take another journey on a UFO. While doing so, we would be jumping from one relativistic frame to another. You would see the energy of the earthly light beam slowly and slowly decrease as your velocity increased. You would reach a point to where the light is so stretched it becomes almost unnoticeable. Now let's move backwards along this trip. Assume you are accelerating at light speed away from infinite velocity, and instead of accelerating away from the Earth, you accelerate towards it. The wave of the light you would originally see would be extended to infinity, and then slowly and slowly the light would then fabricate into the light of the earthly frame, once the velocity of the bodies is the same. You would never physically move towards the Earth, you would simply accelerate towards it until the velocity differences are the same. What you would see is a shift from long waves to short. What's interesting is that these particles already exist as long waves at the edge of the universe, and it takes a certain amount of time for the particle of the source's frame to arrive. When considering physical space now, it would take an infinite amount of time for the light as seen from the earthly observer to arrive at the edge of the universe. Whereas in the subject moving at infinite velocity, it is already there and takes no time. This shows the potential for building a device that may be able to see the future. Space preparation conclusion. A particle or wave exists in all moments in space and time in at least one or more relativistic frames of motion. Space must first be prepared from long waves to short as particles or photons move through space, or rather manifest. This space preparation can be sensed and therefore measured and computed. Although current technology may not yet exist to capture this in motion, it is a real possibility, and the concept of future imaging does exist. Gravity from above. One of the most fundamental forces in nature is gravity. It is the physical attraction of matter, and its force may accurately be measured by using a variety of equations. However, why are people so convinced that gravity pulls? Could there be a basic set of equations that considers gravity as a pushing force instead? Perhaps it is a force from time itself. Sir Isaac Newton. The story of Newton and the fruit tree is well known. He was sitting underneath and then saw a fruit fall. He wondered why. What he claimed was there was a force that attracted the fruit to the earth. He then made equations. Common equations. Some of the most commonly used equations when calculating the force of gravity is F equals ma and F equal to gmm divided by r squared. F equals ma is good for when comparing a much smaller body to a larger body, and the force of gravity is already well known. F equals gm big M little m divided by r squared is great for celestial bodies within the galaxy. Very quickly, F is the force of gravity, which is related to the masses of the objects and the distance between them. But the universe is expanding. That's simple enough. However, at extreme distances, say the length of the universe, there are laws that aren't really applying. Intuition would tell us that the universe should be contracting, or at least slowing in its expansion. However, it is still expanding. From this, it is obvious that something is missing, or that is being approached improperly. Consider now the source of gravity coming from an outside source, instead of coming from the mass of the object. Maybe it's from above. Yes, let's pretend that gravity comes from above, instead of the Earth. How could that work? Electromagnetic waves carry momentum with them. You can physically move objects with lasers. A perfect example is getting a piece of lightweight tinfoil and shining a powerful blue light at it. The tinfoil will jump. So maybe the force of gravity comes from light. Even more added energy could be coming from the particles or photons when you consider all the relative frames of motion. How could this work? Imagine a free-floating body in space not near any planets or stars. The force of gravity is zero because there are no stars next to it. It is neither being pushed or pulled in one direction. This does not say anything about where the force of gravity is actually coming from. All it says is that the forces are balanced, all adding to zero. This body could have billions and billions of tons acting on it, but all the forces are canceling each other to make no motion. All the stars in the universe. Here is a case that has a free-floating body in space. There are still billions and billions of stars and a smooth cosmic background for this example. Either these stars have zero effect on the body, or they have their natural effect. I would argue that they have their natural effect. Each star in existence emits essentially every wavelength in existence, from infinitely short to infinitely long. Each star pushes on each other, and you could say that space and time is dense with electromagnetic waves. In any point in space, there's essentially every wavelength of light coming in from all directions. There is a sort of universal mesh, and the universe is like liquid light in that fashion. Now let's add a massive planet to the scenario. What would a planet do to light coming in from all directions? The answer may be obvious. It would get in the way. So you see, a planet or any physical body is actually blocking light. The planets and other masses would be acting as shields. A new definition for gravity. The force of gravity could then be equated as interstellar star pressure, P, minus shielding, S. The interstellar star pressure would be the force of natural light waves in any point in space and time and would not be constant in the universe. It would depend on the number of stars and varying wavelengths, all creating a general light state. Your equation would then look like F is equal to P minus S. This is a very simple equation and works wonders in the universe. Not only does F equal P minus S, but F equals big G, big M, little m divided by R squared for closed ranges. So you could assume that F is equal to GMM divided by R squared is equal to P minus S. Remember, the answers are already there. The force of gravity will always be 9.8 meters per second squared for Earth. Therefore, P minus S of Earth is equal to 9.8 meters per second squared. All the answers are already out there, and it may help to redefine our methods for some scenarios. The approach. The rate of expansion is known from observations. The force of gravity at relatively close distances is known. From this, we could find that the value of P at any point in space, P is equal to F plus S. So what is S? Well, S is the shielding force, which is created by any mass as it blocks, or rather interacts with, interstellar light pressure or energy. By using many different examples of known gravitational forces, we may approximate a reasonable interstellar P. Just like the equations for gravity that exist, the amount of shielding pressure would be related to the amount of mass and the distance squared. P would be the summation of energy of all light in space and time, including those of different relativistic frames. This would give a vector account of star pressure and direction. A simple example would be to say that P is at maximum at the center of the universe, where it is being bombarded by light from all directions. The resultant energy is equal to zero because all the forces would cancel out. Then you could say that at the edges of the universe, the total force would be due to P because there would not be any shielding sources. In short, you could say that shielding is equal to zero at the edges and that the expansion is due to interstellar star pressure of sorts. Relationship to the expanding universe. Now to relate this to the expansion of matter at extremely large scales and the compression of matter at extremely close, objects near one another are essentially pushed together. They have equal forces acting on them. However, objects near the edges would want to be pushed apart. It is a very simple concept that explains how the universe could be expanding, yet matter is attracted to itself. Points where S is equal to P would be turning points of physical attraction or repulsion. Walking through walls. Have you ever wondered if you can walk through walls? The idea may seem like fantasy. All evidence in your day-to-day life says that if you walk into a wall, it will stop you. Well, that is not the case with particles such as photons and neutrinos. These objects have the ability to pass through objects without any interactions. Why then may a photon pass through a wall and not a person? The main problem is interference of magnetic energies between the photons or particle and the electrons of the shell of the atom. Here is a theoretical solution. Light is a very tricky guy. It can be seen as a photon which has mass or a wave which does not. Very quickly, a wave of light may be comparable to a wave of water at the beach. The wavelength of the wave is the distance from one wave to another. Their frequency is the number of waves that would pass by any point in a second. There is a direct relationship between wavelength and frequency. Waves are awesome in many ways. One of the most interesting features is a wave's ability to add and subtract from one another. If you were to have two waves in the same exact size, but in opposite directions to where the top of one wave perfectly matches the bottom, then the two waves would cancel out. Much energy could exist, but there would be no physical indication because the two waves would be nullifying each other. However, after they pass, the two waves would return to their normal state, and you would see both of them traveling away as if nothing ever happened. Waves have many interesting properties. One of them is that they may bounce off of barriers or objects. Have you ever noticed an echo in a canyon? It is essentially your sound wave bouncing off of different objects. Light waves can bounce as well. However, for now, we are speaking in terms of sound because it is the easiest to relate to in our day-to-day lives. Another easy example to see in nature is in water waves. You can see this as water waves bounce off of channel walls. Next time you see water bouncing off of a channel wall, watch as the bouncing waves overlap with the incoming and form nodes. Standing waves. By using the knowledge of how waves build and how they bounce, it is possible to create standing waves. A standing wave is a wave that appears to be frozen in time. It is the result of perfectly timed overlapping waves. Standing waves have many unique characteristics and may be used for many applications. One fun usage of standing waves is for the levitation of objects. Objects want to be in zones of low pressure. You can control an object by controlling a node of low pressure. You can make the object go higher, lower, to the side, or whatever you want to do. It really comes down to being able to control the node. Standing waves can vary in length and size. The number of waves available for any system typically depends on the size of the container and what is in the container. Let's say the container in this case is a swimming pool that is 10 feet long. Now we create one wave that is 10 feet in length. You will see you have created one standing wave with one node. Now let's send a wave that is 5 feet long. You will see that we now have created two standing nodes. This trend continues for every common factor. If you want 4 nodes, then you divide 10 by 4 and you get a wavelength of 2.5. The point, and I stress this point, is that there are common wavelengths in which standing waves may form, and those depend entirely on the size of the container and the velocity of the wave. These common lengths could be considered factors of the total length of the container. What's interesting about waves is that they are somewhat independent of the median. Yes, the median does control the speed at which the wave may travel, but the median does not control the source of the wave. Imagine a pool of water. It has no waves. The water is just sitting still and being water. However, if we were essentially to massage the water in just the correct fashion, we could make a hole where someone could pass through without getting wet. We could potentially make a swimming pool that floats in midair. The elements. The elements are a creation of particles. Typically, there is a nucleus that contains protons and neutrons, and then an electron shell that contains some electrons. A simple example of an element is hydrogen. Each element is characterized by the number of these particles. Hydrogen has 1 electron, helium has 2, and so on. The number of electrons and protons determine the size of the atom. For our purposes, it would be directly related to the size of the swimming pools from the example before. By creating standing waves in the elements, it is possible to change the phase or spin of magnetic energy associated with it. Similar to moving water up and down in a swimming pool, we could make electrons or protons move them around with electromagnetic waves. A common factor. Just like swimming pools vary in size, so do the elements. Imagine you have 2 swimming pools but only 1 wave machine. How do you get the swimming pools in sync? You would have to find the common factor. This will allow the 2 pools to carry the same standing wave energy. You can theoretically find the common factor of several pools to have them in harmonic phase with one another. This may also be true for electromagnetic waves and elements. Each element has its own orientation and size. By finding the common factor of electromagnetic energy, we may be able to tune them to one another. In other words, we can make a wall that has all particles electromagnetically in phase with each other. The easiest way would be to imagine if you have a wall composed of a solid element like gold or iron. The diameter of these metals are already well known. We could create a standing wave within the materials that compose the wall and then do the same with the rod. We would essentially have the rod and the wall tuned to the exact same phase, and theoretically the rod may be able to pass through the wall with absolutely no interference. Manipulating gravity. Using our new theory in gravity, along with the concept of space preparation, we may now theorize on manipulating gravity. This would be our ability to create more or less gravity in a desired location. Considering the force of gravity comes from an interstellar star pressure or overlapping of waves, could there be a way to manipulate these waves? The answer is yes. Through our understanding of waves, we know that they will either add or subtract from each other. The light state of the universe. Consider the concept of a light state within any physical spot in the universe. Light state could be considered the total amount of all electromagnetic waves that is passing through that point. Light state would vary at every point in the universe because of relative shielding and pressure sources. It could be considered a sort of snapshot of the electromagnetic state. The liquid light state universe. This really does lead to the question, is matter just nodes of overlapping electromagnetism? Does it even make sense to say that gravity exists? Could it be a resultant illusion created by space preparation? All waves overlap and their energy adds and subtracts. Matter is always in a constant form of manifestation, blipping in and out of solidity. Is it not just temporary waves passing through continuing onward? Are we not peaks of the same wave? Does the photon not only become matter to another photon when the conscious observer is accelerating at light speed in the same direction? Let's continue on our conscious journey as the liquid light state universe examines the universe as if it is all light. Matter forms at nodes of overlapping electromagnetism. We also discuss the conscious field and light state harmony via the Cartesian mind, body, and spirit diagrams. Thank you for listening, and I hope you have a wonderful day.